So far in this unit, we have been talking about the idea of a relation. A relation is a relationship between two variables, an independent and a dependent variable, an x and a y. In this toolkit, we're looking at a special type of relation, a relation called a function. And a function is a relation in which each input has exactly one output. Exactly one. Let's highlight that. Circle that. Bold it. Exactly one. Circle, bold, highlight. Exactly one output. Looking at this picture right here, this is a really helpful picture to think about what a function is. You can think of a function as a machine, a function machine, in which you input an input. When you stick an input into the machine, don't want to cover that up, and inside the machine something predictable happens. The function always does the same thing such that the exact same output comes out every time. Same input, a particular input, function machine, something predictable happens such that I know exactly what output I'm going to get. I get the same exact output every single time. In this toolkit, we look at some non-math examples of functions, and then in future toolkits, we'll look at more mathy examples. Example number 1, my input is the name of my city. My output is the name of the state that that city is in. So let's look at this. Input into my machine, city of Seattle. Output is Washington. Input, city of San Diego. Output is California. Input, city of Bothell. Inside my function machine, I ask my function, what state is this city in? The output is Washington. Input of Olympia. Output, Washington. Always predictable. When I ask you, what state is the city of LA in? California. So input of city, output of state. This is a function because given each input, the output is always the same. Always the same. Always the same. Bothell, always Washington. Olympia, always Washington. LA, always California. It does not matter that Seattle and Bothell and Olympia all go to the same output. What matters is that given one particular input, or each particular input, the output is predictable. Please notice that if we reversed input and output and said my input was state, my output is give me a city in that state, that would no longer be a function. If I said, hey, my input is California, inside my function machine, give me a city, sometimes I'd get San Diego, sometimes I would get LA, so it would not be a function. Let's look at this next example, which we are going to just think of the typical case, a unicycle, one wheel, bicycle, two wheels. Just assume every bicycle in the world has two wheels. Every motorcycle in the world, let's say this is true, two wheels. Tricycle has three wheels. A car has four wheels, and I'm going to change this to minivan. And every minivan in the world has four wheels. So let's take this as reality. And taking this as reality, a vehicle as the input, number of wheels as the output, this is a function. I give you a unicycle. Inside my function machine, I'm going to say, how many wheels is on this vehicle? You're always going to predict one. You're always going to have an output of one. If I asked you to bring every bicycle into the planet, assuming this were true, that would be my input. Hey, what's this vehicle? My output would be predictable. Every single bicycle in that room, number of wheels, 2. What's important to notice here is that bicycles and motorcycles both have 2 wheels, and cars and vans both have 4, and that is okay. What matters is that if I have a minivan convention, every single minivan in that place, I can predict number of wheels on each of those cars or on each of those vans is 4. Again, reversing, no longer a function. Input of how many wheels, output of vehicle. If I say, hey, tell me a vehicle with 4 wheels, some of you will say car, and some will say van, and some will say truck. So which one's the input, which one's the output is important. Last example, I guess we'll go back to blue. Input of a word, output, how many letters are in that word? So I'm going to stick inside my function machine the word dog. Inside the function machine, my function's going to count how many letters are in this word, and out's going to pop my output of 3. Input of cat, output of 3, 3 letters in that word. Input of box, output of 3. Input of cup, output of 3. This is okay. This is a function. They all have an output of 3, but given a particular input, the output is predictable. Frog 4, star 4. Again, in this case, if I reversed it, this is not a function. If I said my input is a particular number of letters, my output would not be predictable. So if I gave you all a slip of paper, hey, give me a 4-letter word. I would never do this, but if I did this, hey, give me a 4-letter word, it would not be a predictable outcome. It would not be a function. Let's move on to the non-examples. So again, we are going to take this table as reality, no details, no rotten cranberries, no unripe strawberries. Every cranberry in the world, just trust me in this reality, every cranberry is red, every strawberry is red. This is a function thus far. If we all have a strawberry eating contest, every single strawberry in the room will be red. A cranberry juicing party, every cranberry will be red. It doesn't matter that both of those fruits are red. What matters is, given my input of the type of fruit, the output of color is predictable. Where it all falls apart is with apples. Hey guys, let's eat apples to celebrate the last day of school. Well, some of those apples are going to be red, some are going to be green, and a few might be yellow. So this is the part right here that makes this a non-example. This is not a function. Not a function. Each input does not have exactly one output. Cranberry has exactly one output. Strawberry has exactly one output, but apple does not. Sometimes apples are red, and sometimes they're green, and sometimes they're yellow. So if I stick the fruit type of apple into my function machine, the output of color is not predictable. Another example over here of not a function. 30 days past September, April, June, and November. All the rest have 31. So January has 31, March has 31, May has 31, February has 28. And if I stopped right here, this would be a function. It's okay that January has 31 days and March does too and May does as well. This is a function. The problem is, well, not the problem, the thing that makes this not a function is good old February. So in a leap year, February has 29 days. Oh, that's supposed to be red, not pink. So February is what makes this not a function, because in a leap year, February has 29 days. So if I say, hey, how many days are in February this year? The answer may be 28, it may be 29. So not a function, not because of January, not because of March, not because of April or May, but because this one single input of February has two different outputs. Two different outputs means not a function.